Hi, my name is John Goheen, and I am going to do a presentation on the sustainability analysis of lithium-ion batteries. First of all, a little bit of an introduction. The purpose of this is kind of to complete a life cycle analysis of a lithium-ion battery and to kind of discuss the manufacturing processes, sales, the energy used, that sort of thing. Also, we're going to mention a little bit about the demand, how the demand has increased over the last few years. A lot of this is due to personal electronic devices and electric vehicles, as that is starting to gain momentum in today's industry. So a little bit of background information on this science. Lithium as an element was discovered in 1817, but it wasn't really studied until the 20th century. It was really just regarded as more of like a mineral. Um, Lithium. So how a battery works actually is lithium is kind of placed right in between, as you can see in that diagram. It is actually placed in between different salt solutions, and these salt solutions actually react with one another and create energy. But that lithium is able to essentially block that transfer of energy and reaction between these two elements. So that is kind of how the lithium-ion battery became an idea. It can hold a charge, and as technology has improved, popularity has increased, the technology has increased. Batteries can hold a lot more of a charge. So Uh, so for the first part of the life cycle, we're going to be talking a little bit about the materials, the pre-production, raw materials, additives, pre-processing. Um, Really, when it comes to these batteries, the most important material is the lithium ion. The lithium, the cobalt, the manganese, all these rare earth metals that are really only found in specific areas of the world, such as China, Republic of Congo, Argentina, just a few examples of these places where these materials are found. They're usually found in kind of clusters, so only in these specific areas can you really find these elements. But once they're mined, the vast majority of them are sent to China. This is due to their more relaxed restrictions on environmental preventing the environment from um, being contaminated. Greenhouse gases, they're very relaxed on that. That's the reason a lot of manufacturing is over there. Labor is cheap, and there's very little restriction. So about 60% is actually sent to China. So for the life cycle stage two, this is just going to discuss a little bit about the manufacturing. Um, the lithium-ion batteries are usually designed and manufactured to fit certain scenarios. For instance, like an iPhone. Your iPhone battery is designed specifically for an iPhone. Usually they are made by companies such as Samsung or LG, but in this case, they're designed for a specific purpose. You can buy lithium-ion batteries that are more general use. They come in a size like a double or triple A. But for most circumstances, these batteries are for specific devices. So like batteries for electric vehicles, those are produced by different companies, Samsung, LG, Panasonic. Um, but a lot of these raw materials are transported to manufacturing facilities for the final assembly. Um, like I said in the PowerPoint here, the final assembly is reasonably unclear other than this graphic. The graphic gives you a little bit of a rundown on the overall like manufacturing of these, but to get actual lithium ion manufacturing processes is difficult due to a lot of confidentiality agreements. They don't want to leak their procedures, protocols. So as you can see to the left there is that little bit of a diagram on just giving a general rundown of how some of these lithium-ion batteries are created. So life cycle stage 3 is kind of talking about the marketing and distribution, sales of these batteries. Usually these assembled batteries are marketed to technology companies, sometimes consumers a little bit, but mostly technology companies, automotive. These companies usually, in best business practice, it's best to buy from one of the lower price sellers. Now, you always got to regard quality. Quality is a big deal, so you want to make sure your product still has that same quality. So sometimes to go for the cheapest isn't the best option, but to get the best quality for the money is the best. The batteries are usually shipped by rail or truck to the purchase company for final assembly. That's where they will be assembled into your iPhone or your uh, Tesla cars, things like that. And there in that picture there is just kind of the Tesla assembly line, because Tesla batteries will be installed on the assembly line instead of being built in-house and then sent to the assembly line. So the life cycle for is the kind of the use of the raw materials, the amount of energy used to create these batteries. As you can see, lithium-ion batteries take a lot of energy to create. It takes almost 65 times the power to produce as what it contains. So for instance, if you had a 1 kilowatt battery, it takes 65 kilowatts to produce that 1 kilowatt battery. So really this is an area where there could be a lot of improvements in sustainability to improve. If we could get that number down by half, um, it saves a lot of money, saves the environment. It's just a better case scenario. And then, of course, the end of life for these batteries. Lithium-ion batteries can only hold a certain number of charge cycles, just like your phone. Usually, if used every day, batteries, especially like, for instance, electric vehicles, will lose at least 2% of their battery capacity each year. These batteries can be recycled by local electronics companies, by hazardous waste companies. Best to contact these companies and not just throw them away, because then they're just going to go in a landfill. Send them to the right people, and they can take the materials out of these batteries to use in either new batteries or reuse these batteries as a whole. So, as you can see here, electric vehicle batteries, I think in California actually, have been used for storing electricity from solar arrays, just as kind of backup. I know California pushes a lot of electric. They have a big push towards electric vehicles, so a lot of these batteries will end up, hopefully, instead of being in landfills, to help out kind of sustain the grid a little bit. And they also hold a pretty large value due to their rare earth metals, like I mentioned before. A lot of these rare earth metals can be reused if recycled properly. So a few other issues that I want to mention. One issue isn't up here, but it's actually, I remember this a few years back. There were some safety concerns with lithium-ion batteries. One of the first big cases of this was the Samsung, I think it was the Galaxy S5, the Note. The Galaxy S5 Note there used to be problems with it exploding. The batteries would catch fire. I don't remember the exact cause of these problems, but I remember them banning them on airlines, so you couldn't fly if you owned this cell phone. It was a big deal. And then they finally improved the technology and got rid of that issue. But as you can see also, General Motors recalled the Bolt EV this last year for 16 vehicles catching fire, causing lots of property damage, as you can see in those photos. This is believed to be caused by an issue with internally in the battery with the anode. Similar scenario with the Samsung S5 Note. Instances like these have kind of created a pushback from consumers with the lithium-ion batteries. A lot of consumers are worried about lithium-ion batteries in the fact that they're worried that they're going to sustain property damage or have their car catch fire, which is a pretty very understandable why there would be the concern for that, and that's why we are constantly improving on these issues. So just to kind of discuss some of my research, some of the things I've found. Improved technology will create longer lasting batteries. Battery technology itself has improved a lot over the past few years. A battery of a certain size from a decade ago, uh, if you have a battery from today that's about the same size, it can usually hold 2, 3, 4 times what that battery from a decade ago could contain, how much energy it could contain. Most of the rare earth metals are only found in distinct regions. I know the US is trying to get into that now. They're trying to start mining these rare earth metals in certain areas, like Alaska. And also, without the proper refining and manufacturing practices, the lithium-ion battery industry is reasonably unsustainable. Without refining, without finding a way of refining, without emitting all of these toxic gases into the atmosphere, there is really no way to produce batteries without it being pretty toxic for the environment. Even the mining, that can disrupt the ecosystem around the mines. And then, of course, disposing of these batteries, which, if not properly disposed of, they're not sustainable at all. And as you can see in that photo, that is a man disposing of his batteries by the ocean, which is a incorrect way of disposing batteries. Not kind of more of a joke than anything. Definitely don't dispose of your batteries by the ocean. A few conclusions. So lithium technology has greatly advanced for the last 50 years, and demand keeps growing. Batteries start off as raw materials that are mined from the earth. Once these materials are refined, they are sent to manufacturing facilities where they are manufactured into lithium-ion batteries. These manufactured batteries are then shipped to the final assembly plants after they are purchased by whatever corporation is doing the assembly. So, and then usually after that, these devices are sold, and then by the time they reach their end of life, they are collected by local companies to recycle out rare earth metals, and then be reused either for, like California there with the solar arrays, or other uses. Few recommendations I have. Improvements need to be made for the lithium-ion battery production and use to make it more sustainable. Just like I mentioned before, the refining is very toxic and should be researched. There can be many improvements made. I know if we do bring some of this battery refining and whatnot to other countries with more restrictions, the technology will become better to keep the atmosphere clean, make this a much more clean process. And then, of course, improved recycling can be introduced to recycle 100% of used batteries. I know right now not 100% of batteries can be recycled. We're at a spot where there are some parts of the batteries that can be recycled, but it's still a problem in the end of how sustainable are these batteries. And then, of course, my reference page. So, thank you for listening to my presentation, and have a good rest of your day.